Okay, it looks like, Rachel, it looks like you've, I hope that's your name. It looks like you got the right answers on here. But anyway, let me show you how I would do it. Okay, so the first one says use the doubling time of 2 years and the 4004 processor as starting information. So we know that t equals 0 will represent 1971. And we know that at that time, the number of transistors is 0.023 million. Okay, so we're going to use an exponential model. So the exponential models are a of t equals initial value times b to the t. So we've got to figure out what all these things are. So big A represents the number of processes. Yep. And T represents time since 1991. So we do know that the doubling time is 2 years. So we can put 2 in for T because it's the doubling. And we know that if we were to double the initial amount after 2 years, it would go from this to double that. So it would be the amount after 2 years would be 0.0046. All right, so what we do now is we plug all the stuff in and we figure out what that B value is. So we're going to get 0.0046 equals 0.0023 because P represents the initial amount of processes times B to the 2. So then we'll divide both sides by 0.0023 and we'll get 2 equals B squared. So we can take logarithms or we can just take the square root. So I'm going to take the square root. So I get B equals the square root of 2, which is 1.414. It wants it wants 4 decimal places, 1.414. Okay, so that's part A. And then part B is just putting the data in and creating the model. So I think you're okay with that. Again, you have the right answer. So that is 8B. So now we're going to do 9, which is very similar. All right, so number 9A says that the half-life of penicillin is 20 minutes. So T is 20 minutes, but we're going to do, it's H, sorry. H is 20 minutes, but we have to do 20 minutes in terms of hours because the function says hours. So I'm going to do 20 minutes is what? A third of an hour. Good. All right, or 0.33333 hours. Okay. All right, and we know that it's the half-life of the penicillin. So we know that at the time when we inject the penicillin in or take the penicillin, the initial amount of penicillin, which we're going to call P, is 250. And so again, we're going to use the same formula because it's an exponential model. Okay. And I'm going to do H instead of T. I apologize. All right, so we know that when I plug in, I know that H of a third, A of a third is going to equal the half-life. So that means I'm going to have half of this. So I'm going to plug it all in. So I have 125 equals 250 times B, which I don't know, to the 1/3. Okay, so I'll divide both sides by 250, and I'll get a half equals B to the 1/3. And what kills the 1/3 power? You can use logarithms, but I'm just going to cube both sides. So when I cube both sides, I'll get 0.125 equals B. Okay, and then it looks like you're okay with the other part of it. So my function will be A of H is equal to 250 times 0.125 to the H. Hopefully that helps you. Oh, and the one up here, the model would be a of t equals 0.0023 times 1.4142 to the t. So there we go. So you can solve these problems in many different ways. That's probably the easiest way. All right, bye.